Hello, Namaskar. This is P.V. Sudarshan from the Department of Chemistry, St. Joseph Pre-University College, sharing with you some of the valuable inputs to help you assess and grade yourself better in the coming CET examination. I am here again to share with you some of the valuable inputs of P block elements. I have categorically categorized this subject and this topic into three segments. In the first segment, we'll be talking about the oxidation state, hybridization. In the second segment, we'll be talking about the trends. In the third segment, we'll be talking about chemical properties and then the relevant important that need to be assessed in this chapter. Let me go ahead. As you all are aware that P block elements, one of the widely known topic to be the best for the students to score maximum marks in the annual examination. This is also one of the chapter you need to put in lots of efforts to get maximum reward in your CET examination. So what is that I'm trying to tell you all is how to prepare this P block elements. This is a chapter that will help you, if at all, if you have little bit love towards the chemical reaction. So let me start off with the first segment of today's session, that is how to find the oxidation state. And believe me, this is one of the questions which has been asked plentiful times in various papers. Therefore, I thought this would help us to do better. In the first question that I am going to discuss with you, I have what is the oxidation state of nitrogen in N2O, NO and NO2. You all are aware in the first year PUC you have studied redox reactions. In redox reactions, you have studied how to calculate the oxidation state. But in this, the synapse that I want to give you all is nitrogen, the first element of group 15. In this nitrogen, we know that the oxidation state of nitrogen ranges from -3 to +5. The highest oxidation state being +5. The highest oxidation state being +5. Under this, I would like to tell that if I happen to work this numerical, I have N2O, I have NO, I have NO2, and we know that it has to fit into this category called -3 to +5. Let me work this numerical with you, and I'll be really fast in helping you out in assessing this. If I happen to take the numerical N2O, which is being devised in the question, you know how to calculate it. I will be calculating it as the unknown factor here is nitrogen. Therefore, the most probable and the frequent oxidation state of oxygen is -2. Therefore, -2 is equal to 0. 2x is equal to 2. Therefore, x is equal to 1. I understand that nitrous oxide oxidation state is equal to +1. One more tip I'm trying to give you here is whenever we assess, do not try to look in for all the options. Look in one of the option which carries the reward. For example, in this question, I have N2O which is showing +1 and I don't have anywhere in the option other than the first option which gives me +1 in the first position. Therefore, the most relevant answer would be and the most appropriate answer would be the first one. I complete the question again. NO, which is nitric oxide, if I want to find it out, NO, x minus 2 is equal to 0, x is equal to +2. Yes, matching and working to my standards. Hope you have understood this numerical. Dear students, I hope you have understood the first question. And as I'm talking to you, you would have started working on the second question. Let's apply the same principles that we have adopted for the first question. In calculating the oxidation state of phosphorus in the given oxyacids of phosphorus. So you are very well aware for H4P2O5, I work it in this fashion where hydrogen, I know that the oxidation state of hydrogen is 1. Therefore, 1 into 4 is 4. I need to calculate the oxidation state of phosphorus. Therefore, I write it as 2x plus oxygen, I am aware that it is -2. Therefore, 5 into -2 happens to be -10. Therefore, 2x is equal to 6. X is equal to 3. Going by the logic that I have devised to you for the previous problem, where I had said that if you happen to find the first answer, look in for the options where probably you have the answer. In this, I understand that plus 3 is the answer for the first one, H4P2O5, and this plus 3 appears only in option D. Therefore, without making a second thought or a second attempt, please go for it. Therefore, it is plus 3, plus 4 and plus 5. You can verify it later. My dear students, believe it once again that success in CET only depends on your hard work and the skills that you adapt. It's not how much time you take to solve a numerical, but how fast you're able to judge with a relevant answer. That brings a prominent change. Let's go into the third question. This third question is very important for me. Again, why am I discussing this is, we adapt the same principle that we have adapted for the first question and the second question. For example, I am reading the question for you again. Oxidation state of sulfur in Carnot's acid and Marshall's acid is. This comes under group 16, oxy acids of sulfur. This question is relevant because these are the only two oxy acids which have got an exceptional case. Carnot's acid and Marshall's acid, they are read as peroxomonosulfuric acid, peroxodisulfuric acid. This Carnot's acid and Marshall's acid, if I happen to give the formula for you, Carnot's acid, the formula is H2SO5, while for Marshall's acid it is H2S2O8. Now, going by all probability, if you happen to calculate the oxidation state of sulfur in Carnot's acid and in Marshall's acid, you will land up getting the answer as plus 8 and plus 7. But by all probability, this is wrong. What I want to say is, this is a special case. And why it is a special case is because these two have got peroxy linkage, and therefore try to get this direct into your head. Carnot's acid, Marshall's acid, oxidation state of sulfur is plus 6 and plus 6 only. No doubt that when you calculate by the oxidation state methodology, you land up getting plus 8 and plus 7. Therefore, don't be fooled by the option, but kindly go with this, that is plus 6 and plus 6 only. I would like to repeat this once again. Carnot's acid H2SO5 is read as peroxomonosulfuric acid, whereas Marshall's acid peroxodisulfuric acid. Going on to the third one, oxidation state and hybridization of the central atom of hydrides of group 15. You all are aware what are group 15. Group 15 is nitrogen family. Nitrogen family is also known as nicogens, understandably that they are all pungent in odor. All elements of group 15, undergo reaction with hydrogen to form hydrides of the type, I would like to mention this, undergo reaction with hydrogen to form hydrides of the type EH3, understanding that my E happens to be the element. Under this, EH3 hydride, NH3 ammonia, PH3 phosphine, ASH3 and so on as I move down the group. In all these cases, the oxidation state of the central element happens to be -3. Work it out. You have NH3, X is for nitrogen, X plus 3 into 1 is equal to 0. Therefore, X is equal to -3, understanding that the central atom in hydrides of group 15, oxidation state of it is -3 and the hybridized state of it is sp3. I'd like to spend some more time in helping you how did I get that hybridization. In the next question as I move on, I'll be explaining to you the concept of hybridization and how to get it at a gunshot methodology. The correct answer for this question is option B, -3. Hybridized state of this is sp3. I'll be explaining this concept in the next question. Dear students, let's begin today's session with that question which has been repeatedly asked in various examinations. So I would like to enlighten you to tell that the oxidation state of an element calculation is very important in P block elements, whether it may be in group 15 or group 16 or group 17. Since you already have a fair idea about this in the first year PUC, you have studied about redox reactions, so let me deal with it now. So how do I answer this? What is the oxidation state of nitrogen in N2O, NO and NO2? Let me give you a fair idea about the oxidation states of nitrogen. Nitrogen can exhibit a maximum oxidation state of +5 and the lowest oxidation state is -3. The range of oxidation state of nitrogen is from -3 to +5. I have with me nitrous oxide, nitric oxide, nitrogen dioxide. So let us categorically work this. If I happen to calculate the oxidation state of N2O, the unknown element here nitrogen, I write it as 2x plus -2 is equal to 0, 2x is equal to 2, x is equal to 1. From this, I understand that in one of the options that I have, the first answer should be +1. As I look into the option here as A, B, C and D, I understand that option A has got +1 and none of it begins with 1. Therefore, most probably and relevant answer is your option A. But let me also help you how to solve the remaining things. I have nitric oxide NOx plus -2, which is equal to 0, x is equal to 2. Hope you have understood. Therefore, it matches to the constant 1, 2 and 4. Coming up to the next question, since you have understood the pattern of how to attempt this question, I hope you will try on your own. Let me help you out. What is the oxidation state of phosphorus in the various oxyacids of phosphorus that I have written on the board? I have various oxidation states of phosphorus that I want to devise for this. In this, I have H4P2O5. If I happen to work on the same measure as I worked the previous problem, hydrogen, I am aware it is +1. 1 into 4, it is 4. The unknown here is phosphorus. I want to find phosphorus, therefore 2x plus oxygen. I am aware the oxidation state of it is -2. 5 into -2 is equal to 0. Therefore, 4 plus 2x minus 10 is equal to 0. I understand that x is equal to 3. Again, if you have understood my first question properly, as I said, the first answer should be beginning with +3. I have in the option, that is option D, it has 3, 4 and 5 and no other option begins with 3. Therefore, most probable attempt for this would be 3, 4 and 5. Therefore, I would like to give a tick mark for option D. Try working out and then check whether it follows according to our wavelength. I have the second one, H4P2O6. I have 4 plus 2x minus 12 is equal to 0. Therefore, I understand x is equal to, in this, +4. Therefore, it is matching to my question. Hope you have understood this. Dear students, if you go by the concept that I have devised for you for the earlier questions, you would definitely love to do this question and you will be bubbling with joy telling that, sir, my answer is +8 and +7. The oxidation state of sulfur in Carrose acid and Marshall's acid is, according to your calculation, by all means, you are 100% right. It is +8 and +7. But believe me, it is 100% wrong because this is an exceptional case that I would like to teach you. In this, Carrose acid, the molecular formula of Carrose acid is H2SO5, while for Marshall's acid, it is H2S2O8. What is wrong in this? There's nothing wrong in it. You apply the basics of oxidation state calculation. You would definitely get it as +8 and +7, but these two have got peroxy linkage. This is the point that I would like you to enlighten yourself and hit it directly into your head. Carrot's acid and Marshall's acid, the maximum oxidation state is +6 and +6 only. This is due to the presence of peroxy linkage and not +8 and +7. Therefore, the correct option is option A, +6 and +6. Hope you understood it. Good. Go to the next one. Oxidation state and hybridization of the central atom of hydrides of group 15 is. I'd like to speak a minute about it. Group 15, you all are aware, group 15 belongs to nitrogen family. They are also nicknamed as nicogens, meaning suffocating. All elements of group 15 undergo reaction with hydrogen to form hydrides of the type EH3, in which E happens to be the central atom. If it is group 15, it should be NH3, PH3 and so on. The central atom oxidation state, by all means by your regular calculation, it should be -3, and I hope you are smiling with the answer. Option B is the right answer, -B. Then how do I get this sp3 hybridization, sir? I would like to explain this concept and then go ahead. When we discuss the next question, you will know why it is sp3 hybridization. Dear students, I want you to learn this concept of calculating the oxidation state of phosphorus, which you have mastered by now. Now, how to calculate the basicity, how to remember these formulas. This is one of the questions that has replicated so many times in various editions of various examinations. Therefore, I would like you to master this question. I would like you to again learn the way it has to be learnt. Example, if you look into these formulas, is it easy to mug these formulas? Definitely not. But how I want you all to learn is, just look into the numbers that I have written. 2, 3, 4, 5, 6, 7. They are all in order. H3, 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 followed by H4, H4 and H4. The first three, if you want to remember only one code word. In, on, or. That is all. Chapter closes there. I am again repeating. In, on, or. If you know in, that means it is phosphinic acid. If you know on, it is phosphonic acid. And last one, phosphoric acid. Therefore, just like that, if I happen to ask you H3PO3, what's the name of it? All you need to remember is in, on, or. It is in the second position. Therefore, it is phosphonic acid. Hope you got it. And as you look in for the lower down in the series, I have pyro alternated with one more pyro, the next position. I have hypo in between. And the last three, if you could remember, they end up with ric acid. That is a code word that you have to hold up. It ends up with ric acid. Therefore, the correct methodology to learn is in, on, or, followed by pyro, followed by hypo, pyro, and you end up with meta. Hope you got it. And by chance, now, I tend to ask you, what is the formula for a particular example, hypophosphoric acid? It should automatically come to you as H4P2O6. And what I have written in bracket after the name is the oxidation state of phosphorus in all these oxyacids of phosphorus. I have given only one question for you to work. Since you have worked a couple of questions of the same, this should be easy for you. It is just pick and then paste it here. The